Good morning. Professor Jim Skea, today's guest speaker on the session on petroleum, forests, and climate resilient development. Chancellor John Edward Green, Dr. Thomas Singh, ladies and gentlemen, guests, friends, colleagues. My name is Yeshim. I'm the United Nations Resident Coordinator here in Guyana. It is my absolute honor to associate the United Nations with the University of Guyana's Green Institute in partnership. We've established a partnership this year that will see us sponsoring and supporting a series of presentations and policy dialogues that speak directly to the issue, the triple planetary crisis of biodiversity loss, of pollution, and of course, climate change. The policy dialogues that we plan to support cover a range of issues from economic diversification, green jobs, to urban development, to energy transitions, to climate justice. I'm very honored today to be in the presence, especially of course, all of you, but of course, especially our guest speaker today, Professor Jim Skea, who co-chairs one of the working groups, the Working Group 3 on mitigation of the International Intergovernmental Panel on Climate Change, the IPCC. As you well know, the IPCC is the purveyor of the global science on human-caused global warming, and informs the targets that are established in the Intergovernmental Forum, of course, namely the Paris Agreement. Thank you so much for being with us today. Ladies and gentlemen, perhaps no country in the world exemplifies as starkly the paradoxes, the dilemmas, the complexity of the climate change challenge that the world faces as Guyana does. As you well know, the people of Guyana has not contributed to the global warming, to the climate change crisis that we find ourselves in. Emissions from Guyana have been infinitesimal, to zero to none. Guyana is also home to a vast rainforest, which is a carbon sink for the universe, for the humanity, absorbing in excess of 150 million tons of carbon dioxide every year from the atmosphere. On the other hand, Guyana has huge development needs that it aspires to meet the sustainable development goals for all its citizens. The people of Guyana want and aspire to have and deserve to have better schools, better hospitals, better healthcare, better roads for their children to go to school in. And all of those require finances. And that financing is now being put to use from the natural resources that Guyana has been able to leverage. Ladies and gentlemen, of course, the oil and gas will contribute to climate change. And the downstream eventual use of the hydrocarbons produced in Guyana, the consumption of these hydrocarbons will have negative contributions to the climate challenge. But somehow still, we need to come to grips with this. We need to understand this complexity. And when I say we, I don't mean just the people of Guyana or the policymakers of Guyana, the international development community, Guyana's bilateral partners. We all need to understand this dilemma the paradox that a country like Guyana finds itself in. That's why it's really important to put pen to paper, to use science, to use data. This complexity is why the United Nations Guyana will be associating itself with the University of Guyana and its Green Institute to bring the relevant data, the research, the science, the evidence to bear upon these difficult questions. Through a robust, evidence-based debate, I am confident that we can make meaningful contributions to strategic decision-making in Guyana, but also contribute to the world of policy, to the global policy-making in this field. I'd like to thank Professor Skea once again for being with us here today during what I understand is the most ambitious cycle of the IPCC's work in the world. Thank you so much for being with us. Of course, my heartfelt gratitude to the University of Guyana and the Green Institute, and to Professor Singh for associating himself and his research team with our joint endeavor. I wish you the best in today's session, and wish for a productive and fruitful discussions, and I look forward to our cooperation going forward. Thank you.
Much, Professor, and for those welcoming remarks. And I also join in a hearty welcome to you, Professor, so as not to detain us from your own presentation. Please allow me to invite you to present to us this morning. It is my pleasure.
Okay, thank you very much, Chancellor, and thank you very much for your kind remarks, Jose. And just to say, it's quite a pleasure to be with you and be presenting in South America. Very often in South America, it's our Spanish-speaking colleagues who take the lead on this. So this is a really very good opportunity for me to make contact with people on the continent. Just to say, it is quite a warm afternoon here in London, although the worst of our heat wave is over. And I'll share this presentation with you over the next sort of half hour or so. Now, one thing I might say just as an introductory remark is, as officers of IPCC, we are commanded to be policy relevant, but not policy prescriptive. In other words, not to make recommendations about policy specifically, nor to make comments on the situation of individual countries. So I'm stretching this just a little bit in making this presentation, and I've chosen the title carefully. I'll be talking about IPCC findings that I believe may be relevant for Guyana. Really up to you to decide on that, whether it is in fact relevant. So let me see if I can move this on. So what I'm going to do is split the presentation into 4 sections. And the first one may sound a little bit dry, accounting for carbon dioxide emissions and other greenhouse gases, but especially for countries that whose emissions are closely tied to land use, and especially forests. This issue of accounting for carbon dioxide is quite a tricky one. So I'm going to spend a little bit time on that. Then, largely because of Guyana's interest as an energy producer, I will move on to the idea of net zero and the future energy systems, with some thoughts about Guyana's position on that, has already been remarked. I also want to talk about CO2 removal, because net zero will not be obtained unless we actually take carbon dioxide out of the atmosphere. And finally, with a slightly different hat on, I want to look at the idea of just transitions, that is, taking account from an equity and justice point of view what the social economic implications of a transition to net zero might mean, and how these transitions might be managed. So with that, I'll go straight into it. So here is straight from the most recent IPCC report. This is what global emissions of greenhouse gas emissions look like since the year 1990. Big messages here: emissions are continuing to increase, though the rate of growth might be slightly slower in the last decade than it has been previously. We'll just flag up that carbon dioxide from fossil fuel and industry, the blue slice here, accounts for almost 2/3 of greenhouse gas emissions. Just over 10% of it, and this is where it gets a little bit controversial, is net carbon dioxide emissions from land use change, and forestry. And then the remainder comes from other greenhouse gases like methane, which is quite short-lived, nitrous oxide, and fluorinated gases. Now, just one point to make is that there is no really known way of getting gases other than carbon dioxide out of the atmosphere. So that's nitrous oxide, methane, and the fluorinated gases. And so when we get to net zero greenhouse gases, it means you need to take carbon dioxide out of the atmosphere and not put it in. And it also has the implication that the timing of net zero greenhouse gas emissions will always be later than net zero emissions from carbon dioxide. And it's worthwhile remembering that a lot of national pledges for net zero have been made in terms of greenhouse gas emissions, and it may be that net zero carbon dioxide, which IPCC talks about, would need to take place about 10 years or even 20 years earlier. Now, in terms of looking at emissions or sinks from land use change and forestry, we have a bit of a dilemma here. We often talk about the working groups of IPCC, but there's a more hidden part of IPCC, the Task Force on Inventories, that develops the methods by which countries report their emissions or sinks to the UN Framework Convention on Climate Change. And 30 years ago, our colleagues in the Task Force on Inventories dealt with the problem of how you deal with carbon dioxide from land use. And basically their method of measurement is to take the carbon stock in an area of land or in a forest at the start of period, compare it to the carbon stock at the end of period, and deduce the kind of changes in carbon storage that may have taken place. But what they cannot tell is whether that change in stored carbon took place from human interventions or took place from, say, the natural growth of the forest. So our colleagues in the Task Force on Inventories took the pragmatic decision to say that to define some land as being managed and some land as being unmanaged, and that the emissions reported to the UNFCCC are all changes in carbon dioxide, whether natural or human-based, that are coming from what they called managed land. And this is their definition of managed land. It is land which has been applied to provide production, ecological or social functions. And frankly, it's up to individual countries to decide how to meet what is managed and what is unmanaged land, because the second bullet here says that only broad and non-prescriptive definitions are provided for the land use categories. So as long as countries are transparent and consistent, they can choose their own definition of managed land. And what this means that is, for example, if there's a group of indigenous people living in a forest, that can count as managed land, although they don't make any meaningful level of harvesting of the wood products. So what does that mean in terms of how we measure greenhouse gas emissions or carbon dioxide emissions? The global models on the left side of this picture, which were used to estimate the timing of net zero carbon dioxide, use quite a narrow definition of what is managed land. They talk about only areas in which there is active harvesting. And the global models do not account for the natural growth on that managed land. But in the greenhouse gas inventories on the right-hand side, there is a wider definition of managed land, and the inventories also include the natural fluxes that take place on that managed land. Now, this makes a big difference because the global models estimate about 5 gigatons of carbon dioxide globally, whereas the greenhouse gas inventories take account of about 5 gigatons of sinks, which cancel it out. So if you add up the greenhouse gas inventories, it basically gets to net zero carbon dioxide from land. And that 5 gigatons, believe me, is causing a lot of discussion within the UN system and the Framework Convention on Climate Change. So just looking at very specifically what this looks like for Guyana, I've taken the IPCC logos off this because basically I've pulled this information myself from other sources. If we go to the International Energy Agency, these are the emissions of carbon dioxide from fossil fuels and industry in Guyana. And basically, it's about 2.5 million tonnes a year, and it amounts to about 3 tonnes of carbon dioxide per capita. And that compares with a global average of about 5 tonnes of carbon dioxide per capita from fossil fuels and industry. And that is made up basically electricity in Guyana, a big chunk of it, transport fuels, bit from industry, bit from agriculture and forestry, and a very little bit from residential and commercial buildings, which would be much bigger in a country like the UK. And you say most of that electricity emissions are coming from, I think, emissions of oil burning. So Guyana is absolutely less than the global average on emissions from fossil fuels and industry. Now, I also tried to get information, which was much harder to do actually, on the land use and non-CO2 emissions from Guyana. And just to say, Guyana has submitted its second national communication to the Framework Convention in 2012, and the emissions data in that applied back to 2004, so this is somewhat out of date. But basically, the conclusion was that carbon dioxide emissions from land use and land use change were about 4.5 million tonnes of carbon dioxide equivalent, non-CO2 emissions about 3, which is giving you a total all of about 10 million tonnes. It's about 11 tonnes of carbon dioxide equivalent per capita, which is actually slightly higher than the global average because of the relatively high level of emissions from land use and land use change. But as one of the speakers at the beginning pointed out, Guyana also has a big area of forest. And when I looked at this national communication, about 15% of the forest in Guyana was defined as managed land, and the carbon dioxide removals from that managed land at the time I looked were about 60 million tonnes of carbon dioxide equivalent. So just to say, in terms of the models that IPCC working groups run, Guyana is a net emitter. If you take account of the inventories and the sinks in the forest, then Guyana is absolutely net negative already, and there's a lot of carbon dioxide being taken out of the atmosphere. So I think that's a very useful point just to get up front about this question of accounting for greenhouse gas emissions. And of course, whether these CO2, natural CO2 removals from managed land, can compensate for emissions elsewhere, I think it's a policy question and debate that would need to take place within Guyana. So moving on to the second part of the talk on net zero emissions and the energy system in future global scenarios. And I think that, again, this is being pulled out from the most recent Working Group 3 report of IPCC. And what this is showing, there are an enormous range of emission scenarios out there, which IPCC has assessed in its reports. And it's divided them into a number of different categories. So the orange slice, and this is total greenhouse gas emissions on the left-hand side, carbon dioxide on the right. We've picked out scenarios that are consistent with the kind of pledges that governments have made, the NDC, Nationally Determined Contribution Range. The light blue are scenarios that are compatible with limiting global warming to 1.5 degrees, and the purple, which is slightly higher, are emissions associated with scenarios that would be likely limited warming to 2 degrees, and that's sometimes been described as well below 2 degrees, though it's not actually for IPCC to say that. So the key point is that in these 1.5 degree scenarios, basically emissions carbon dioxide emissions over here need to reach net zero somewhere in the 2050s. If you are going to go to scenarios which are compatible with limiting warming to 2 degrees, that can be a bit later. The 2070s is the average of the range across different scenarios. Greenhouse gas emission net zero can come much later. For the C1 scenarios, the compatible with 1.5 degrees, it's in the 2090s. And in fact, in these 2 degree scenarios, global greenhouse gas emissions do not reach net zero within the 21st century. And just to say, that's not necessarily compatible with Article 4 of the Paris Agreement, which talks about balancing removals and sinks in the second half of the 21st century. So the big story is 1.5 degrees for carbon dioxide, which does not take account of natural sinks. We would be looking at net zero in the 2050s, for 2 degrees sometime in the 2070s. Now, these are enormously ambitious scenarios. They involve cutting emissions by, say, 40% by 2030 compared with current levels. So what actually happens within energy systems in these kinds of scenarios? And that is something that the IPCC report has gone into a lot of detail in. First, fairly obviously, a very substantial reduction in fossil fuel use, which I'll come on to. A minimal use of fossil fuels unless they are abated with carbon capture and storage. And carbon capture and storage could play a big factor, taking emissions out of flue gases and storing it, for example, in depleted oil and gas fields. Electricity is particularly important and would reach net zero before most other sectors. So electricity systems that emit no to almost zero net carbon dioxide would be part of the picture. And going along with basically net zero electricity systems, it would then make sense to make greater use of electricity in the energy system, in uses such as transportation with electric vehicles, or in countries like the UK, where we still need to heat our homes using heat pumps rather than gas-fired boilers. There may be some other sectors in which other energy carriers have a role to play: sustainable biofuels, low emissions hydrogen, and other hydrogen-derived fuels like ammonia might be a possibility. And the energy sector as a whole would need to change quite significantly. And it would almost with institutional, physical, operational integration. And to cope with more variable renewable energy in the system, there's a lot of interest in other techniques, like, for example, having demand-side integration, where, for example, some electricity uses are turned off when the wind drops or where there is less solar radiation. And already we're seeing these being integrated into electricity systems in the UK, for example. It may not be possible to get carbon dioxide everywhere out of the energy system, and there may be a need to counterbalance any other emissions with removals of emissions in other sectors. Now, just to flag specifically, we have a big story about renewable energy, and renewable energy has actually been a big success over the last 5 to 10 years because the price has dropped considerably. That goes for both solar energy and wind, whether onshore or offshore. Costs have fallen so that renewable energy can basically compete with conventional energy like gas, for example, in most electricity systems now. It's coming through just as almost lower cost. And there are some countries and regions where already we've got renewable energy is dominating the system. In Scotland, where I come from, renewable energy output is actually higher than electricity consumption, and we're exporting some of that electricity, so it's physically possible to do it. It is very challenging, however, to supply the entire energy system with renewable energy. The last few percent may be quite difficult because you need flexible generation like natural gas to balance the system, but it's going up. Overall, about 10% of electricity is now coming from wind and solar globally, and it is growing at an enormously fast rate. So things are moving, and there are measures that you can take to integrate these large shares of variable renewables into electricity systems. And you've got the list at the bottom. Linking sectors, energy storage, and the falling cost of batteries has been important there. Smart grids that can balance demand and supply, and making use of sustainable biofuels or other means to balance the system at the margin. So there's a very optimistic picture actually in the IPCC report about the role of renewable energy. That is obviously a different picture for fossil fuels, and this shows what would happen to demand for the different fossil fuels, coal, oil and gas, in different scenarios. These are central estimates, and there's quite a range within the different scenarios that's being published. So basically, coal is the most carbon intensive fossil fuel, followed by oil and then gas. And broadly speaking, a gas-fired power station, modern gas-fired power station, would have about half the carbon emissions as coal for a given amount of electricity. So you can see that whatever the ambition that is compatible with the Paris Agreement, well below 2 degrees, coal use would have to go down very significantly globally in all of these scenarios. Oil use and gas use would also go down quite significantly in a 1.5 degree scenario, but that's more sensitive to the level of climate ambition. So for example, in a 2 degree scenario, natural gas use globally would go down by about 15% in the middle of the range. And it is worthwhile saying that if you do not apply carbon capture and storage to coal, oil and gas, then there really would be very substantive reductions. A lot of the gas that's used in a 2 degree scenario is actually fitted with carbon capture and storage to allow its use to continue. So big changes in terms of fossil fuels globally. Now, getting a little closer to the situation in Guyana and trying to think about the future, we actually talked quite a lot about stranded assets in terms of fossil fuels, because limiting global warming to 2 degrees or below will still leave a substantial amount of fossil fuel reserves currently proved up that could not be burnt if you're going to limit warming to these levels. And there's also other fossil fuel infrastructure like coal-fired power stations particularly that would cover. Obviously, carbon capture and storage, that's what CCS stands for, could allow fossil fuels to be used longer and would potentially reduce the level of stranded assets. So just say the combined value of unburned fossil fuels in these scenarios, in a 2 degree scenario, could be somewhere between $1 and $4 trillion basically between now and 2050, and could be even higher in a 1.5 degrees scenario. And just to say, we have a very clear message that it's coal, assets associated with coal are really at the risk of being stranded even before 2030, while stranded oil and gas assets are much more at risk towards mid-century. So just to say, any additional reserves that are added to the system will, if we are going to limit warming to these levels, will actually leave these assets, some assets, stranded in the future. And the question is not so much whether assets will be stranded. The question is whose assets will be stranded, which kind could be there. And we're obviously aware that some parts of the world have built their industrialization and their current standard of living on using current assets. And in the approval of the IPCC report, we actually talked a lot about historic responsibility, for example, and the ethical issues associated with what developed countries versus developing countries might do. And I've been most conscious of the views of especially of countries in West Africa like Ghana, which I think are in a situation just a little bit ahead of Guyana here in South America in building up a fossil fuel oil and gas industries, which will, as has already been said, can pay for other kinds of development needs. Just one thing to flag about the question of oil production and how it appears in terms of countries' ambition. This is actually a picture from the National Academies in the US. The units don't matter so much. What really matters is the balance between the different parts of these columns. So what it's showing is the greenhouse gas emissions and carbon dioxide equivalent associated right across the supply chain with running a gasoline fueled internal combustion engine vehicle. And the blue part are the emissions when you're actually burning the fuel in the vehicle, and that obviously dominates the whole picture. The feedstock is the amount of carbon dioxide that is emitted in order to produce the oil that goes in there, and the pink part of fuel is the carbon dioxide emissions associated with, say, refining the fuel and turning crude oil into something that can be burned in a vehicle. So just to flag, in terms of how this would all affect Guyana's emissions inventory, The blue part would not appear on Guyana's inventory at all, because we're presuming that most of the oil would be exported. The feedstock part of it, wood part, the yellow slice, would appear in Guyana's emission inventory. And the pink part would depend on where the refining is taking place. And I imagine the refining actually might take place outside Guyana. So the pink part would also not appear on Guyana's inventory. So from a point of view of an oil and gas producer, actually there's not so much emissions associated with actually producing. The production is taking place downstream. And certainly in the UK, where I come from, which has offshore oil and gas production, the industry there is aiming for net zero as an industry, presumably much of which would be achieved by purchasing carbon credits to pay for removals elsewhere. Which brings me neatly on to the next part of the talk, which is to talk about carbon dioxide removal and the importance of measurement, reporting, and verification to make carbon dioxide removal credible. So it's just a reminder that in terms of forest systems, it was mentioned at the beginning that we have 3 global crises around pollution, biodiversity, and climate. And this is a quotation from the IPCC Special Report on Climate Change and Land that came out about 3 years ago, which focuses on the point here that preserving and restoring natural ecosystems, including forests, and looking after biodiversity conservation is really got to be tied together with adaptation and mitigation responses. And that taking these steps to preserve and restore natural ecosystems will enhance ecosystem function and other societal goals. So this was a very important point that many of our colleagues wanted to make. Now, for the first time in IPCC, we actually paid a lot more attention to carbon dioxide removal in the most recent report, quite simply because net zero emissions are not achievable unless we take carbon dioxide out of the atmosphere to compensate for remaining carbon emissions and emissions of other greenhouse gases. And what we really picked out in the report this time was the huge diversity of different approaches to carbon dioxide removal. And you can basically divide them up according to 3 criteria. What is the process by which carbon dioxide gets removed from the atmosphere? That's in the top left-hand corner. Is it biological, on land or on ocean? Is it geochemical, or is it purely chemical with things like direct air carbon capture and storage? At the bottom of the slide, you have the medium in which the carbon dioxide is stored, and that could be in harvested wood products and buildings. It can be sequestered in vegetation and soils, and agricultural practices have a role to play there. You can sequester it in geological formations, which is what would be anticipated with carbon capture and storage. And finally, there is the other criteria. How long does the carbon dioxide actually stay there once it's sequestered in these storage media? And basically for biological systems, it could be decades to centuries. And for geological, it could be millennia or even longer. But the challenge, I think, about forest systems and the more biological ones is that the carbon dioxide storage can be reversible, either by human intervention or by natural events like wildfires. So it is incredibly important that we measure the way that carbon dioxide is remaining stored, reporting on that measurement and verifying that it is actually taking place. So this is a really important part for kind of managing these ecosystems. And just to flag, we picked up a number of issues that would need to be addressed to take account, and you consider the permanence of carbon sequestration, which supports the integrity of emission trading at the project level, and particularly important, the importance of standardized indicators, developing credible certification schemes, standards, and codes of practice, on developing regulations on transparency and verification. And none of this can happen unless you build up institutional capacity and you apply the most recent technology to measuring. And there's some very interesting techniques coming through for assessing carbon dioxide in the atmosphere and doing reverse modeling backwards to discover how much carbon dioxide is either being emitted or putting into sinks. So I just wanted to emphasize, that for a country like Guyana, this could be quite important to take account of these factors and measuring and verifying how much carbon is being sunk, emitted, or is being traded if that does take place. Now, I just wanted to spend a couple of minutes, not too long, on a final part of the talk, which is on the idea of just transitions. And this has come to the fore very recently. It wasn't actually scoped into the working group reports in this cycle, but it was scoped into the synthesis report, which we are currently working on. And for that reason, Working Group 3, we paid a bit of attention to the idea of just transition in the report that's just come out, though the literature is very at quite an early stage there. And basically just transition came from the idea, it mainly came from the coal industry and thinking about what happens to communities if coal production is run down in response to the need for net zero emissions. And since then, the concept has expanded quite a lot. Now I'm going to switch my logos quite a lot just for the last few slides. I mentioned earlier that I do come from Scotland, and one of the things that I'm doing at the invitation of the Scottish Government is chairing a Just Transition Commission in Scotland that is thinking about the net zero target and what the wider social and economic consequences would be. And the reason I wanted to flag it, although Scotland and Guyana are very obviously different countries, I mean, Scotland's population about 5 million, Guyana just under 1 million, they're smallish countries. But Scotland also has big issues about land use and land tenure, and also has a fairly mature offshore oil and gas production industry, which is now running down. And there are big considerations about employment and the implications for communities, which we're starting to think about. So we have this definition of just transition that we used, that we have used in Scotland to try and guide us. And basically that it's about designing policies in a way that ensures the benefits of climate change action, which do exist, are shared widely, while the costs don't fall unfairly on those who are less able to pay or whose livelihoods depend on the industries that may be run down. So that is basically what it was about. We were asked to provide practical, realistic and affordable recommendations for Scottish ministers to take account of the opportunities from a net zero economy, build on existing strengths and assets, and understand how to mitigate the risks that could arrive in terms of equalities, poverty. Just to flag that we actually expanded the concept of just transition. It wasn't just about the fossil fuel industry. It wasn't even just about the supply side. We're thinking carefully about the impacts on consumers, and this is particularly heightened because of the rise in both energy and food prices as a result of the Ukrainian crisis at the moment. And it's not just about future injustices, because every country has its own existing injustices. And in Scotland, we're concerned about land work, land tenure, we're concerned about fair work, especially with the kind of the Uberization of the labour markets. And we have big concerns about the amount of money that people need to spend to keep their homes warm. So with this process, we developed 4 sets of sort of overall guidelines about doing things that I think are actually quite generic. And the first one is the really importance, if you're going to have a just transition, needs to be orderly and it needs to be managed. And this really emphasised the importance of a planning framework for future, being very clear about where you want to go in the future. Second one was about equipping people with the skills and education that they need to benefit from the transition. Some skills from the old economy are transferable. For example, divers on oil and gas platforms can be divers on offshore wind platforms. That's transferable. But there's also a need to skill up in new kinds of ways to deal with the new kind of industries that are going to be needed. The importance, the kind of the procedural justice part of it, making sure that communities are fully part of the kind of the planning for a transition to net zero is important. So we were really emphasising the importance of empowering and invigorating communities, strengthening local economies. And the final theme was this issue about sharing benefits widely and ensuring burdens are distributed on the basis of ability to pay. And just to say again, the current situation in energy and food markets really is showing you that these costs are falling unfairly on those least able to pay at the moment. So tying the climate crisis together with other challenges that we face at the moment is really important. So every country needs to do a just transition in its own way, but I thought I would share some of the thinking that I've had in a different kind of context from IPCC about the way forward. So that, in fact, brings the presentation to an end. Thanks for paying attention. I hope it was proved interesting and useful, and I'm very, very pleased to take part in any Q&A or discussion to follow. I'll just stop sharing my screen now.
Thank you very much, Professor Skea. This was a most fascinating presentation. You helped us to understand how this IPCC sixth assessment report integrates knowledge more strongly across the natural, the ecological, social, and economic sciences. And this is more so in this report than in former assessment, if I would try to make a comparison. But what is important, I believe, for the discussion that we must have is that your presentation illustrated how climate change impacts and risks, as well as adaptation, are set against a range of unfolding non-climatic global trends like biodiversity loss, overall unsustainable consumption, and things like that, land and ecosystem shifts, and those things that you've mentioned that have led us to understand and realize that the ending that you have provided us, the just transition, is something that countries, especially countries like Guyana, must consider. And I think that when we look at your presentation, it provides us with somewhat of a template of trying to grapple with issues related to the theme of your talk, forests, petroleum, natural gas, and the future of economic development. I really thank you so much, and I'm sure I speak for all of those, of what I thought was a very fascinating presentation. But before we move into the next phase of the discussion, I'm asking participants to take a couple minutes to respond to a short poll which asks you about your assessment of the webinar so far. We will have one now, and we will have one at the end of the interactions with Professor Skea. So if you look on the screen, and if you could quickly respond, it's yes, no, to 2 questions. And it should take you no longer than 1 minute and 10 seconds. And while you're doing that, so as not to waste much time, and in order to carry forward the discussion, I want first of all to call on Dr. Ulrich Trutz. He has already been introduced by Dr. Singh, but I want to indicate that he is one of the scientists in the region at the cutting edge of discussions that we have, which could help us to really put in context and to connect up with what's happening here in the Caribbean and Guyana. His presentation will be around 10 minutes, after which we will move to the Q&A session, which hopefully will be about 20 minutes before wrapping up the webinar. So I want to now move us on and ask Dr. Ulrich Trotz if he will make some comments.
Thank you, Professor Green. Good morning, everybody. And thank you, Professor Skea, for that excellent presentation. I see my job basically is to more or less show what are the implications of the IPCC report for Guyana's situation with respect to climate change and its recent oil and gas bonanza. Coming out of the IPCC report, it has informed policy at the level of the convention. Hence, we have the Paris Agreement, where basically we have agreed that to keep the global warming below 1.5 degrees by the end of the century would require us to achieve a net zero carbon, net zero status with respect to greenhouse gas emissions by 2050. Now, this requires, as part of global action to achieve this, phasing out of fossil fuels and conservation of forest estate, two major actions. Now, what's the global scenario as we move forward? There are a few realities that we need to face. First, at the present rate of greenhouse gas emissions, the business as usual scenario, we are on the track to see 1.5 degrees warming, not by the end of the century, but by 2040. That was out of the latest IPCC report on the implications of 1.5 as opposed to 2-degree warming. So for us, the message that time is important and urgent action is required to address these issues. The present greenhouse gas concentrations is a second implication in the atmosphere is already having significant impact on our climate. We're seeing floods, droughts, forest fires, landslides, loss of life, everyday reporting. So we are living in a world that is committed to climate change. And it's for us, particularly in poor developing countries, in fact, globally, it's imperative that we take urgent action to adapt, to build resilience to these impacts. The other reality we have to face is that we, as the world transitions to a net zero situation, fossil fuels will be a part of the energy equation. That is, we'll have to be using fossil fuels as we make that transition. And for us, finally, particularly for us in developing countries, both adaptation and mitigation require significant resources. And that's where we in developing countries find ourselves in a trap, in that the international community have been unable to provide developing countries with the necessary resources for the transformation to net zero and for building climate resilience adaptation at the level and in a timely way. As I said, we are running out of time and we need urgent action. So let's look at our situation in Guyana. We possess both the forests and recently oil and gas. How do we deal with the management of our oil and gas resources? Now, fortunately, we do have the LCDS, the Low Carbon Development Strategy, and it speaks to phasing out, achieving the net zero status. And one of the major actions under that umbrella is forests, dealing with forests or forest conservation. And there is a lot of intent there about monetizing the ecosystem services derived from forests and basically generating revenue to implement their adaptation strategies. In fact, Guyana is already deriving benefit from forest conservation through an arrangement with Norway. Just reflect for a minute that Norway is a big oil producer. And even very recently, when we're talking about phasing out fossil fuels, they have announced that they're going to extend their exploration for oil and gas in their system. This underlines the fact that fossil fuels are going to be with us for some time. Now, there's an option that we should keep the oil and gas in the ground. But this basically would only be an option if the international community would pay us, they compensate us for not bringing that oil and gas out. For us, our major incentive here basically is to get our hands on the resources. And if we use those resources to accelerate the pace at which we can move to a net zero situation in Guyana, and also at the same time to build our climate resilience, strengthen our coastal protection, etc., implement adaptation measures, then we would have moved at a quicker pace to attain net zero status and climate resilience. There's also a tremendous opportunity here, basically, if we could extend this resources and that we have in Suriname and Guyana and Trinidad, basically to accelerate the movement of the entire CARICOM region through provision of the resources to do so, for them to attain net zero status and also to build climate resilience. Right now, all of our countries have basically plans to do that. These have been submitted in their NDCs and in their national adaptation plans to the UNFCCC, but their resources aren't there. What I am proposing is that if the resources that we attain from oil and gas can be utilized to accelerate our movement as a region to a net zero status, internalize all of the requirements. Recently at Heads of Government, for instance, they're talking about going back to Venezuela for a Petro-Caribbean arrangement to provide them with fossil fuel at this point in time. Could we internalize that instead of a Petro-Carib, a Petro-CARICOM, so that the resources are internal? We basically have control of the supply chains, etc., and we accelerate the whole region to move in that direction. One interesting fact came out recently, the Rystad report that speaks to the fact that Guyana's production system, basically the energy intensity, is about half of the global average. And this more or less encourages us to think about, say, a carbon tax on the production, which will insensitize basically further action to even further reduce that energy intensity. In a nutshell, what I'm saying is that our present situation allows us, provides us with an exceptionally excellent opportunity to show how poor developing countries like Guyana, Suriname, can face the paradox of being a fossil fuel producer and at the same time espousing the tenets of the Paris Agreement and the global imperative to achieve a zero carbon world by 2050. And Professor Skea, I will also like to recommend very highly the principles that you more or less elaborated in your last few slides about what are the requirements for what you refer to as a just transition. I think Guyana would do well basically to espouse those principles, particularly as it speaks to equity and for inclusivity and for ensuring basically that all are involved and that all benefit. Thank you very much.
Thank you so much, Dr. Trotz. I think that we just had a bit of a master class in how there is some synergy between the broad-based issues raised by Professor Skea and the applications that you have sought to help us to make, especially in the context of the Guyana Development Thrust. I'm tempted to ask Dr. Skea if he had any immediate reactions, but I wonder if you would bear with me, since I note in the chat that there are some questions that really bring the two things, ask questions about the two presentations at the same time. And I wonder if it might be expedient for me to take a few of those questions, have both you and Dr. Skea and Dr. Trotz attempt to respond, and then go to some others that are outside of the parameters, but related to the discussion. First,